Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz Dat and as ever I am the IT Geek. Welcome back to another episode. I think this is episode 5 if I'm not mistaken.
It
This
is.
is AZ700 Designing and Implementing Microsoft Azure Network Solutions. Um, so I'm just about keeping count now. When it gets to about halfway I will lose count because that happened with the SC300. After about 20 episodes I was like I have no idea what episode it is anymore. It all kind of blurs. So yeah, this is the exam prep series for the AZ700, like sort of networking exam for Azure. Um, this is part 2 of a 3-part sort of series, sort of mini topic around designing and implementing point-to-site VPN connections. As ever, I am joined by my good friend Saj. Hi Saj, how are you?
I'm good, Shabazz. How are you, man?
Good man, alhamdulillah, I'm all good. It's we had a good first part of this subtopic, didn't we, around point-to-site VPN, where we spoke about the different connection types, and I mean you showed sort of the radius authentication, and I touched on certificate-based authentication as well. And I think we talked about SKUs and the different SKUs as well. So it's quite a lot of interesting topics within there, wasn't there?
So yeah, we covered quite a lot in there. Unfortunately, we couldn't demo end to end, but yeah, we covered all the prerequisites for setting up radius authentication, the fact that we support site-to-site VPN, because it needs line of sight for you to enable it. You went through the SKUs, so yeah,
Yeah.
take a look.
I,
It was very informative.
And I think with again the points that we've made are going to benefit people in the exam. I think we've showed them in the portal where you can configure it. They've got the URL to the GitHub Labs to do it themselves. But I think the main thing was getting across some of the points that might get people in the exam. So I think it was definitely a worthwhile episode. Let's get started with the boring part, my mundane tones and the theory. I know everybody's looking forward to the lab. Um, so yeah, so we're back with still on module 1, which is sort of the hybrid networks element. And this is part 2 of the design, implement, and manage point-to-site VPN connection. So we're going to talk about planning and configuring open VPN connection or authentication. This is something Saj is going to take a look at in closer detail in the lab. We're then going to look at planning and configuring authentication by using Azure AD, which is part of obviously Microsoft Entra. Entra? Entra. Entra. I'll say Entra. I'll stick with Entra. Let me know in the comments what you think it is.
And I think it's so.
Good. And then, yeah, as I said, Saj is going to do a demo on OpenVPN authentication. So, first topic, let's look at planning and configuring OpenVPN authentication. So, as I said, let's talk about planning and configuring OpenVPN authentication. I'm going to use again another diagram to try and explain kind of how the process works of connecting. So here we have our sort of client device with the connection. So that's our OpenVPN client. And they're obviously situated somewhere, anywhere. And then here we have our Azure network. So this is our virtual network. And we can see we've got a subnet there of 172.16.1.0/16. That's got a lot of addresses, but that's our overarching network. But within that, we have our OpenVPN subnet. So again, within that /16 address range, we have a 172.16.1.0/24. So that's 250 odd addresses, and we have our OpenVPN server. We then have that connection. So this is where the OpenVPN client makes connection with the actual OpenVPN server, which is within Azure, within that OpenVPN subnet. And then that allows that client device, which is successfully connected to that OpenVPN server, to connect to obviously to access different managed service and resources. And then within that, we have 2 different subnets. So that's just kind of a little high-level overview of how the connectivity works. But if we look at the actual components that were in that diagram, so we had our OpenVPN subnet, we had our NSG as well, so we had our one network security group for the OpenVPN subnet. And we also had an undefined number of subnets as well. So we had 2 subnets. So we had 3 technically. We had the OpenVPN server one, and we had those 2 other subnets with the managed services on. But again, we have 3. You can have multiple ones. Could be 4, 5, 6, however many you need. Then we have the OpenVPN server. So this is a CentOS-based virtual machine. And then to the far left, we obviously had that client desktop with the internet connection, and that contains that OpenVPN client. So the CentOS-based VM will contain the OpenVPN server. So that's what we kind of saw within Azure. And that's will be used to create that VPN based on an SSL v3 or TLS v1 protocol. You know, many client network implementations require the internet access. Require that internet access is routed through proxy servers. So for this reason, the OpenVPN server listens to port 443, which is that HTTPS kind of default port. Normally, this port is not filtered by proxy servers, so that's why it uses it. Okay, so a bit of an overview of sort of how the OpenVPN connects. So also just continuing with this topic, the OpenVPN server is an Azure subnet, and it will receive all incoming requests from those VPN connections. The important task the server does, it'll execute, is its IP masquerading. So if we talk about that in a bit more detail, this is a form of network address translation, or NATing, through which it is possible to alter that VPN server's incoming communication to look like they're originating from somewhere else. So it kind of masquerades, as it kind of implies, the IP address. Acting in this way, the packages can be routed freely on that VNet, and they can reach their destination. In this case, the VMs that they need to manage. And in our diagram, we had managed servers, didn't we? If you remember. And with this, even IP forwarding is not needed, since there are no route rules which send traffic to the NIC, and that isn't a real destination of the network traffic. So IP forwarding is not needed because of the masquerading. Finally, all sort of incoming traffic is what we call enveloped in the VPN tunnel and in the OpenVPN server, and this will unwrap and then get sent to its destination without the Azure infrastructure actions. So we've kind of covered in a bit of detail there some theory around OpenVPN authentication, which will lead nicely into Saj's demo, which we will be very shortly once we have discussed planning and configuring authentication by using Azure AD. So Azure AD obviously allows users to get to Azure using their Azure Active Directory credentials, cloud native or hybrid potentially. Native Azure AD authentication is only supported for OpenVPN protocol and Windows 10 and requires the use of an Azure VPN client. Okay, so that's one thing to know. With native Azure AD authentication, you can leverage Azure AD's conditional access as well as MFA features for your VPN. So it adds that another layer of security to your VPN connectivity. At a high level, you need to perform the following steps to configure Azure AD authentication. So you need to configure an Azure AD tenant, kind of goes without saying. You need to enable Azure AD for authentication on that VPN gateway. And you also need to download and configure the Azure VPN client. So that being said, let me hand over to my good friend Saj, who is going to cover the demo for us. Over to you, Saj.
Thank you, Shabazz. So setting up a point-to-site VPN. So as part of the demo, we will look at the various tunnel types of authentication that you can use and what they support. So as part of the demo, we will demonstrate using SSTP, which is a proprietary Windows tunnel type. But as Shabazz mentioned, you have OpenVPN, SSTP, IKEv2, and you have the options of IKEv2 and OpenVPN. OpenVPN supports Windows, Mac, Linux, Android, iOS, and there's steps that are required to get that to work. We will share the link with you for you to test that yourself to go through setting up end-to-end the OpenVPN connection. So in this demo, like I mentioned, we'll be using SSTP and connecting to Azure. Just quickly step through the link itself. So it goes through generating the certificates, which is what we'll step through now, and how to set up end-to-end connectivity for that to work. So as Shabazz mentioned previously, you can use enterprise certificates or self-signed root certificates. As part of the testing, we'll be using self-signed certificates. the link it gives you a link on how to create the certificates, both the root certificate and the use certificate using PowerShell. And again, it provides the code for you. So when you're generating the root certificate, run PowerShell on your own machine. Copy the code. The certificate is called PS Child Cert 2. You can rename that to wherever you want. It'll generate a root certificate for you. Copy the code for the child certificate. If you scroll down to find the code for the child certificate, copy the code, paste that into PowerShell. It'll generate the child certificate for you. Again, you can rename it to wherever you want. And then it gets added to the root certificate under personal, under certificates, but in the user context. So the first mistake I made was I ran cert MBR in the computer context. And then I was confused as to where my certificates were. So you need to run it. Even pull this to pop up for me. So if you run it like I did, and you run it into the computer context, you'll find these certificates are not there. So run it in the PowerShell session that you've created and running, and under personal certificates, you'll find the certificates that you've generated. So you need to take a copy of your root certificate, and export it. So if you go to all tasks, advanced operations, export. For your root certificate, select next. You don't need the private key for your root certificate. Select next. You want to export it as base64. Select next. Give it a file name, stick it somewhere, and save. And once you've done that, you can also export your child certificate. Once you've got your child certificate, once you've got your certificates, copy the text from the certificate, because you need the text from the certificate, and navigate to your browser session. In here, if you navigate to virtual gateways, and under configuration, under settings, you've got point to site VPN configuration. If you select give it an address pool, so you want an address pool here, range that doesn't overlap anything you've already configured in Azure or your on-premises environment. Total type, like we mentioned, you've got OpenVPN, SSTP, IKEV2, IKEV2 OpenVPN, and IKEV2 and SSTP. So we're using Secure Socket Transfer Protocol, SSTP for this one. Authentication is certificate. Name your root certificate, copy and paste the text into here, and click save. Once you've saved it, you download your VPN client. Now, downloading it generates a VPN client and then downloads it for you. It can take a little while to do. Once you've downloaded it, you're presented with something like this. So if you then open it up, you get 64-bit and x86 client. Just run and install the client. As part of this, I've already done this to speed up the demo. And you are presented with this. So if you go to home in your settings, navigate VPN settings, it installs it for you. Now if you select and this connects just to prove. So if you select connect, you print with the Azure VPN, connect, and it will connect that for you. Now just to demo this, what we have is a VM in Azure. If we go to our virtual machines, we deployed a virtual machine that has no public IP address. So no public IP address. It has a private IP address of 10.104. So if we run remote desktop connection and add in 10.104, we should be able to hopefully connect to this machine. So put it on the wrong screen there, just drag it over here, and there you go. So we're connected to a machine in Azure over a point-to-site VPN connection from my machine here across the internet, an encrypted link using SSTP to its private IP address 10.104.
Just to prove Sad wasn't pulling the wool over our eyes, he wanted to prove that.
So yeah, so again, you can do this using OpenVPN and it's supported on Mac Linux 10.104. So look at that, show how it works. So just to recap, if you watch the previous sessions, it will show you all the prerequisites to deploy a virtual network gateway. Deploy your virtual network gateway. Go to point site configuration. Generate a certificate, enterprise certificate, or self-generated certificate. We'll include the links within this video, at the bottom of this video. Select Azure certificate. Copy up your root certificate. Take the text from the root certificate that you generated, paste the text in here, save it, and then download your VPN client. And once you've downloaded your VPN client, install it only on your machine. And if you go to your VPN settings, you'll have the client there for you. And just connect, and then connect to any of the resources that you have in Azure.
Perfect. Thank you very much, Sad. Again, another great demo. And with this one, obviously, Sad was able to do a bit more in-depth, configurations and show you a bit more of the end-to-end test. Obviously, ending up with connecting to that virtual machine in Azure from his home PC. So that was a great demo, Sad. Thank you very much.
Happy it worked.
As we said, as Sad just said, we will include the links to some of the URLs that Sad showed in the description of this video, so don't forget to check those out. We'll obviously have mine and Sad's socials, a link to the GitHub labs as well for the AZ700 exam, so please do keep a lookout for those. Obviously, don't forget to comment, like, and most importantly, subscribe. I've said in a few episodes, I'm very open with feedback, so please do give me any feedback that you have. But no, thank you very much, Saj. Thank you everybody for watching. So next episode will be episode 3. That'll be the last part of this little mini topic of point-to-site VPNs. So yeah, thank you, and until next time, goodbye.
Goodbye, everyone.